हेलो सॉरी गाइज, बिकॉज ऑफ सम इमरजेंसी मुझे वो वाला क्लास थोड़ा जल्दी बंद करना पड़ा. आई एम रियली सॉरी फॉर दैट बिकॉज देयर वाज अ इमरजेंसी कॉल फ्रॉम समवेयर, दैट्स व्हाई. तो सॉरी फॉर दैट. चलिए स्टार्ट करते हैं दोस्तों. यहाँ पर हम लोग आगे बढ़ते हैं और क्वेश्चंस को करते हैं जल्दी से. और बिल्कुल जैसे मैंने आपको बताया था दोस्तों कि विल बी डूइंग क्वेश्चंस in the gate format. Okay, we'll be doing questions in the gate format. Okay, so let's start doing the questions. I hope you will be able to do all the questions very easily. So let's start. The very beautiful question दोस्तों. We can see we have a op amp, we have a resistor, we have a Zener, we have a CMOS logic circuit. Okay, so let's start. The CMOS logic circuit has infinite input impedance. Okay, means there is no current in this. So input impedance is infinity. There is no current. Current is 0. Okay, assume that the op amp is ideal. Okay, op amp is ideal. A 1.8 volt Zener diode with minimum Zener current of 2 milliampere. Okay, 1.8 volt Zener diode, okay, is used. The corresponding maximum value of the resistance RZ is what should be the maximum value of this? Okay, so we can see that the Zener diode will be on only when the output here is 5, because we can see that the output of the op amp, we can solve this question, right? Okay, yeah, you can attend this. Okay, so we can see that the output of the op amp, since the op amp is in open loop, so output VO can be plus minus 5 only. You know, VO output can be plus minus 5 only. Now when the output is minus 5, obviously Zener diode is obviously forward biased, but we don't want to keep Zener diode in forward bias. So obviously to keep this Zener diode working, we will keep that output of the op amp should be 5, and when this is 5, the Zener diode circuit, Zener diode should go in breakdown. Okay, now in breakdown the Zener diode voltage is 1.8 volt, and we want that the minimum current here should be 2 milliampere. The minimum current should be 2 milliampere. So we can see that 5 minus 1.8 upon RZ should be greater than 2 milliampere. So RZ should be less than 3.2 upon 2 kilo ohm. RZ should be less than 1.6 kilo ohms. So the maximum value of RZ is 1.6 kilo ohms. How many of you are able to do it? Okay, Zeal bhai has done it. Others, please answer. How many of you are able to do it? 1.6 is the correct answer. Okay, all of you are able to do it, dosto. All of you are able to do it. Now let's see this one, a very beautiful question. Okay. Figure shows an amplifier using the NMOS transistor. Assume that the transistor is in saturation, okay, with device parameter mu and Cox is given, threshold voltage is given. Ignore the channel length modulation effect. The drain current of the transistor at the operating point will be. So we have to find out, we have to solve the circuit at DC, right? We have to solve the circuit at DC. We have to find out the drain current, okay? We have to solve the circuit the circuit are DC. So here we can see that 3.3, 3.3, and we can see there is no requirement of 100 kilo ohm because there is no current in the gate terminal. Okay, now we can see that the no current in this terminal, so ID, this will be the ID current. We can see that the device will be in saturation mode because drain gate is shorted. Okay, now we can see that what is the voltage at this terminal? The voltage at this terminal will be 3.3 minus 3.3 ID. 3.3 minus 3.3 ID. So we can see that ID is equals to half mu NCOX W by L. Yes, VGS is VGS minus VTH 0.65 whole square. Okay, so ID is equals to half mu NCOX W by L, VGS minus VTH whole square. We can put the values. Mu NCOX is 250 microamperes, 0.25 milliampere. W by L is 4. This will be 3.3 minus 0.65 is okay. Now we can solve this. This will be coming out to be 2 ID is equals to 2.65 minus 3.3 ID whole square. Now we have to solve this simple quadratic equation. So 2 ID is equals to 2.65 whole square, 3.3 ID whole square minus 2 multiplied by 3.3 multiplied by 2.65 ID. Just solve this quadratic and get the answer, दोस्तों. So ID will come out to be 0.5 milliampere. Just check it, दोस्तों. Are you getting this or not? ID is equals to 0.5. एक बार चेक करो. 5 आ रहा है मेरा तो. एक बार चेक करिए क्या 0.5 आ रहा है? मिली एम्पियर. तो माइक्रो एम्पियर विल बी 500 माइक्रो एम्पियर. एक बार चेक करो, कोई गलती तो नहीं करी है. 0.3 होल स्क्वायर माइनस 5 0.65 होल स्क्वायर. एक बार चेक करिए तो 5.5 मिली एम्पियर. बट आंसर क्या होगा दोस्तों? व्हाट विल बी द आंसर? 500 माइक्रो एम्पियर. प्लीज चेक ऑल ऑफ यू आर गेटिंग दिस आंसर और नॉट. 0.5 milli ampere, that is 500 micro ampere. I hope all of you are able to get it. Okay. Okay, great. I hope all of you are able to get this. All of you are able to solve this. So दोस्तों, in the exam hall, please don't make any silly mistakes, because these silly mistakes will actually cost 2.66 marks, 2 marks and 2/3 of that. So it will be a very huge loss for all of you. Okay. So let's move on. In the figure shown, R is equals to 1 kilo ohm and C is equals to 0.1 microfarad. For DC gain of minus 10, the 3 dB cutoff frequency is assume that the op amp is ideal. So DC gain is minus 10. So what is the meaning of that? So DC gain is minus 10 means at DC, capacitor is open circuited, okay, and we can see that the gain is minus RF upon R, that is minus 10. So RF upon R will be 10, but that's okay. So we can see that R is equals to 1 kilo ohm, so RF will be 10 kilo ohm. Okay, RF will be 10 kilo ohm. Okay, so RF will be 10 kilo ohm. Now, we can see that the transfer function of this circuit will be minus Z2 upon Z1. We can see it's a inverting amplifier with Z2 is this impedance and Z1 is this impedance. It is equals to minus RF upon SC divided by RF plus 1 upon SC divided by R, that is equals to minus RF upon R multiplied by 1 upon RF SC plus 1. So what is the cutoff frequency? So we can see that the cutoff frequency is 1 upon RF into C. The cutoff frequency will be 1 upon 2 pi RF into C. What is the answer? What is RF? RF is 10 kilo ohm into C is 0.1 microfarad. It is 159 hertz. Okay, all of you are able to get this, dosto. A is a correct answer. Please check, all of you. A is a correct answer. Okay, why others are not able to do it? Why others are not able to do it? Okay, can we move on, dosto? I have studied BJT and MOS amplifier, but I am not confident in concept or while solving the questions. So in BJT and MOSFET amplifiers, the only concept is you have to replace the device with the model and then solve it. But yahi to karna hai. This is the only thing that you have to do. Okay, this is one more question, dosto. In the figure shown, the diode current is given by this equation, exponential equation. Okay. Okay. Where alpha is given like this. IS is also given. The DC current source, op amp and these are ideal. Okay. The change in the output voltage per Kelvin change in the temperature. Okay. So the change in the output voltage per Kelvin, change in the temperature. A very beautiful question, dosto. We can see that 250 nanoampere is the current that is flowing here. So the same current will go in the diode and we can see what is the voltage across the diode. Okay, so what is the voltage across the diode? Yeah, what is the voltage at this terminal? So VA will be the voltage at this terminal will be the diode voltage. Okay, so we can see that ID is equals to IS e to power alpha Vd upon capital T. Okay, now we can see that ID is equals to 250 nanoampere, or we can keep it like that only. So Vd is equals to T upon alpha ln of ID upon IS. Please check all of you. Okay, na? Vd is equals to T upon alpha ln of ID upon IS. Now we can see that the voltage Vd at this terminal is voltage Vd, and this is the non-inverting amplifier. So what is the output? This is 5R, this is R. So we can see that the output is 6 into Vd. That is 6 multiplied by T upon alpha ln of ID upon IS. So it is 6 upon alpha ln of ID upon IS multiplied by capital T. Is this correct? Okay. You can see that it is 6 divided by alpha is 1.16 into 10 to the power 4 multiplied by ln of ID upon IS. What is ID? 50 nanoampere divided by IS is 10 to the power minus 50. So this will come out to be V output is equals to 0.0100 capital T. So we can see that it is VO is equals to 10 capital T. So we can see that for every change in the temperature by 1 Kelvin, per Kelvin change in the temperature, the output will change by 10 millivolt. Please check करिए. All of you are able to do it. Please check. Minus 4.28. नहीं बढ़ेगा तो सही. It will be positive and it will be this. Please check. All of you are able to do it or not. ln of 250 nanoampere. Yeah, this is correct. Okay, all of you are able to do it or not? So the transfer function, this we can see the transfer function is in the pole 0 format, right? So transfer function has to be in pole 0 format, otherwise it will not be able to find out the pole. Okay, without pole or zeros we cannot find the 3 dB frequency. All of you are able to do it or not? Please check. All of you are able to do it, दोस्तों. 10 millivolt change in the output voltage per Kelvin. Okay, all of you are able to do it? Guys, why are you not answering? After 1 month we have a gate exam and you are not able to solve the questions. This is seriously a serious problem. Okay, let's move on. Now a very beautiful question. In the circuit shown, assume that the op amp is ideal and the initial charge on the capacitor is 0. The output voltage at time t equals to 2 millisecond will be. So very simple question. We can see that Initially capacitor is uncharged, and obviously we applied 5 volt here. We applied 5 volt here. Okay, there is a, this is grounded, right? This is grounded. Op amp in negative feedback. Okay, so this is grounded. This is 5 milliampere current. Okay, 5 milliampere current will go here also, and capacitor will start charging. So we can see that the voltage across capacitor will be 1 upon C integral I dt, and we can see that the capacitor will charge for 1 millisecond. 1 upon 2 into 10 to power minus 6. So the capacitor voltage after 1 millisecond will be 5 by 2. So capacitor voltage after 1 millisecond will be this. Capacitor voltage after 1 millisecond will be this. But what happens from 1 to 2 millisecond? What happens from 1 to 2 millisecond? So we can see that after 1 millisecond the capacitor voltage will be this much. But from 1 to 2 millisecond, हमारा input is grounded. Input is grounded. So when the input is grounded, we can see that there is no current in this resistor, because this is grounded, no current here, and no current in the capacitor. So capacitor voltage will remain same. Capacitor voltage will remain same. That is 2.5 volts, and thus we can say that the capacitor voltage from 1 to 2 millisecond will remain same, and the output voltage will be equal to minus the voltage across capacitor minus 2.5 volt. Okay, all of you are able to do it. एक बार check करिए please. All of you are able to do it. Please check. Output voltage. They are asking output voltage, not the capacitor voltage. Okay, I hope all of you are able to do it. So we have to be very careful that what are they actually asking in the question. What is being asked in the question, we have to be very careful. They are asking capacitor voltage, they are asking output voltage. Otherwise, after solving the entire question, we get 0 marks. Okay, I hope all of you are able to do it. Okay, now let's solve this. The op amp in the circuit shown is ideal, except that it has an input bias current of 1 nanoampere and input offset voltage of 10 microvolt. So what will be the worst case output voltage? What will be the worst case output voltage? What will be the worst case output voltage? Okay, so let's solve it. So we all know that whenever we have a bias current and the offset voltage, so in case of the bias currents, we simply apply a current source at the input of the terminals, right? So what is the current? Current is 1 nanoampere. Okay, and we can see that at the positive terminal, we apply a offset voltage of 10 microvolt. Okay, Now we can see that here we have a resistor of 100 kilo ohm and a resistor of 1 kilo ohm. So now we have to solve the question. Obviously, otherwise it's an ideal device. Only these are the non-idealities. So we can apply virtual short, obviously, because the device has infinite gain right now also. Virtual short can be applied. So we can say V plus is equals to V minus is equals to 10 microvolt. So this is 10 microvolt. What is the current here? So we can see that the current will be 10 nano ampere, because 10 microvolt 1 kilo ohm, so 10 nano ampere. So we can see here we have 11 nano ampere. The potential will be 1100 microvolt. Okay, and so output will be 1110 microvolt. Please check, all of you. 1110 microvolt. Let me check one more time. 10 microvolt divided by 1 kilo ohm. 10 microvolt will be copied here. The current will flow here, 10 nano ampere. 10 nano ampere will flow here. The drop here will be 11 nano ampere. 10 here, 1 here. So 11 nano ampere. So 1100 microvolt plus 10. I want all of you are able to do it. Okay, all of you are able to do it, dosto. Okay, let's move on to the next question. In the figure below shows a feedback amplifier constructed using a NMOS transistor. Assuming that mu and Cox is given, threshold voltage is also given, and W by L is 2. The bias voltage at the drain terminal is 4. Okay. The capacitor offers 0 impedance at the small signal. Okay. So we have to find out the small signal voltage gain. Okay. We have to find out the small signal voltage gain. Okay. So we have to solve the circuit at DC, right? We have to solve the circuit at DC, and we have to find out this resistance RS, because without this resistance RS we cannot solve the circuit at DC. Okay, so we have to solve the circuit at DC. First of all, this is 1 kilo ohm. It is given that this is 4 volt. Here we have 200 and 300 kilo ohms. Okay, so we can see that what is the drain current? The drain current is 5.1. We can see that the drain current is 1 milliampere. The same current will flow here, 1 milliampere. This is 5, this is 200 and 300. We can see here we have a 3 volt, 3 voltage. Now we can solve the circuit. ID is equals to half mu n Cox W by L, VGS minus VTH whole square. Now we can see that the gate is at 3, the drain is at 4. So we can see that the drain voltage is greater than gate voltage minus the threshold voltage. So the device is in saturation mode. Okay. Now we can see ID is 1 milliampere. 𝐶𝐸 is 1 milliampere. W by L is 2. So we can see this is VGS minus VTH is equals to 1. Now VTH is equal to 1, threshold is 1, so VGS is equals to 2. So VGS is equal to 2 means here we have 1 volt and 1 milliampere. So we can see that RS is 1 kilo ohm. RS is 1 kilo ohm. Please check all of you are able to do it or not. RS is 1 kilo ohm. All of you are able to do it, dosto. Now we have to find GM, that is equals to under root of two times mu n C ox W by L multiplied by ID. So it is under root of 2 times mu n C ox W by L. W by L is 2. Current is 1. So we can see GM will come out to be 2 milliampere per volt. Okay. All of you are able to find RS, or all of you are able to solve the circuit, dosto. Please check. Now, can anyone find the answer? Can anyone find the voltage gain? What is the voltage gain? 0.667. So now let's find out. So we can solve the circuit at AC now. We have done this in DC. So we have solved the circuit at DC. Now we will solve the circuit at AC again. So now at AC. Okay, and here we have two resistances. Here we have input. Question? Yeah, bhai. Okay, so now here we can see that we can do the AC analysis. So here we can see it is 1 kilo ohm. Yeah, 4 kilo ohm, I think. 1 kilo ohm. 300 kilo, 200 kilo, and here we have in. Now we'll draw the T model. We'll draw the T model, and we can see that this is your gate terminal. This is your 1 upon GM, that is 500 ohms. Here we have 1 kilo ohm. This is your output voltage. GM VGS. Okay, so now we can see that this is your V in voltage. Okay, and this is your V output. So we can see that V output is equals to 1000 upon 1000 plus 500 into V in. That is 2 V in by. How many of you are able to do it? 0.66 or 0.67? Only 2 students have given the answer. What are others doing? This was a simple question, dosto, and if you are not able to do this question, then seriously there's an issue, because dosto, after 1 month we have an exam, and these type of questions should be a cakewalk at this situation. At this situation, these type of questions should be a cakewalk. If you are facing problem, then it means that you have not done practice, you have not studied well. Okay, let's move on to the next question. Okay. In the circuit shown, assuming an ideal op-amp, the value of the output voltage V output will be. Okay, please solve the question, dosto. Just try doing it. I'm giving you 1 minute to answer. I'm giving you 1 minute to attempt the question. हो गया? ट्राई किया आप लोगों ने दोस्तों? Okay, so here we can see that we'll assume that the negative feedback is dominant. Okay, negative feedback is dominant, and here we can see that V output 3R. We can see that by simple VDR the voltage here will be VO by 2, and by negative feedback the V output will be VO by 2 here also, and the input is not given. Let's say 3 volt. Input is 3 volt. Let us say. Now we have to apply. That we can see that the current here will be 3 minus VO by 2. 3 minus 0.5 VO. Minus 0.5 VO divided by 3R. 3 minus 0.5 VO divided by 3R. This is the current. Okay, the same current will flow here. Okay, so here we can see that the drop will be 3 minus 0.5 VO divided by 3. So voltage at this terminal will be, the same current will flow here, right? This is the current. The voltage here will be VO by 2, or that is 0.5 VO minus divided by 3. So it is 1.5 VO okay. So 2 VO minus 3 divided by 3 is this voltage. Okay, now you can see that the current will leave from this terminal. We can solve by KCL also. We can solve by KCL also. We can solve by KCL also. And we can solve. I think we must go by KCL. Otherwise, this will be a lengthy one. This will make it lengthy. Okay. So let's take. We have a voltage VA. We'll apply KCL at two nodes, at this node and at this node. So KCL. Incoming current equal to outgoing current. We can say 3 minus 0.5 VO divided by 3R is equals to 0.5 VO minus VA divided by R. R and R will cancel, 3 will get multiplied. 3 minus 0.5 VO is equals to 1.5 VO minus 3 VA. So we can see that 3 plus 3 VA is equals to 2 VO. We have this equation. Now we'll apply KCL at this node also, beach wala node. You can see the incoming current is 0.5 VO minus VA divided by R is the incoming current, equals to outgoing current. R will cancel, so 0.5 VO so it is 0.5 VO is equals to 3 VA minus VO. So we can simply put VA in terms of from there. VA is equals to 2 VO minus 3 upon 3. 0.5 VO, 1.5 VO equals to A is equals to 2 VO minus 3. Please check all of you. So we can see, we'll go there. The output is 6. Okay. Just check all of you are able to do it or not. Okay, all of you are able to do it. All of you are able to do it. Okay, so let's move on. The next question. The Zener diode is used as a 4-volt voltage regulator in the circuit shown. Given that the diode requires a minimum current of 4 milliampere for voltage regulation, the maximum current permitted to flow through the load is. The supply is not. Okay. The maximum current through the load. So let's say 20 to 30 volt is the supply voltage. Okay. Now this is a very, very beautiful question. Okay. Now this is a very beautiful question. Let's see how many of you are able to do it. I'll wait for all of you to answer. A simple Zener diode problem that all of you can solve. Okay. क्या ये हुआ दोस्तों? Okay, so let's see. So दोस्तों, in this case, because we know that the Zener current requirement is minimum 4 milliampere. Minimum 4 milliampere. The current from behind will be, we can see here we have 4 volts. So we can see that the current, the source current can be the source voltage minus 4 divided by 1200 ampere, because 1200 is in ohms. We can see that the source current can be 10 upon 1200 to 26 upon 1200. Now tell me दोस्तों, what can be the maximum load current? Now दोस्तों, we know that the source maximum current is equals to Zener maximum, if you remember, Zener maximum plus load minimum. All of you remember this, the mummy roti concept, or the concept of varying load current, and IS min is equals to IZ min plus IL max. Now if you want to find out IL max, we have to use this equation. Okay, we cannot take the maximum current from the source and minimum load current and then find the maximum load current, right? So we have to take 16 upon 1200, 14 milliampere plus IL max. Let's see how many of you are able to do it. So it is 13.33 minus 4. So it will come out to be IL max can be 9.33 milliampere. Yes, 9.33 milliampere is the correct answer. Very beautifully done. I hope all of you are able to do it. All of you are able to do it? Just check दोस्तों. This is a very beautiful question. Nicely done. Okay, so let's move on. Okay, the op amp has a gain of 10 to power 4, an input impedance of 10 mega ohm, and output impedance of 100 ohms. Okay, the op amp is used in unity gain feedback configuration. The voltage buffer, the closed loop output impedance will be, okay, giving you a minute time to solve this question. A very simple, beautiful question. Giving you some time to solve. Please solve it. Try kariye. Please try. Giving you some time to solve this. Okay, all of you are able to do it? 0.99. Okay, so we have to solve this question. First of all, we have to draw the op amp model. This is your inverting terminal, this is your non-inverting terminal. This is the input. And the output is connected to the input is connected to the output. Okay. Now we have the impedance at the input. Impedance is at the input we have the impedance, that is 10 mega ohms. So 10 mega ohm, 10 into 10 to power 6. Okay. This is your VA. This is your VB. At the output we have 100 ohms. Here we have the gain of the open loop gain is 10 to power 4. So it is 10 to power 4 VB minus VA. Okay. And this is the output terminal. Now we have to find out the output impedance. So we apply a voltage Vx and assume that the current is Ix, and obviously we remove all the other sources. So we remove the input voltage also. Now we can see that VB is equal to 0, VA is equal to Vx. Now everything is very simple. We can see that this is your Vx voltage. The current here will be Vx upon 10 into 10 to power 6. Okay, the current, and the current here will be, we can easily see what is it. Let me write it. So Ix current is equals to, Ix current, incoming current is Vx upon 10 into 10 to power 6 plus, what is this current? This current is Vx minus this voltage. Now what is this voltage? So Vx minus 10 to power 4 VB minus VA. Now VB is 0, VA is Vx. So this will be Vx minus 10 to power 4 Vx upon 100. These are the two currents. So we can solve this. Ix is equals to 10 to power 7 plus, okay. So we can see that Ix is 10 to power minus 7 plus, this will be approximately 100, 10 to power 4 plus 1 upon 100, approximately 100.01 Vx. So Vx upon Ix will be 9.9. Please check. All of you are able to do it or not? Please check. Okay, please check दोस्तों. It's a very beautiful question. Please check all of you are able to do it or not. Is this correct? Okay, all of you are able to do it. What happens to your health, brother? What happens to your health? Okay, I hope all of you are able to do it. Let's move on to the next question. Okay, this one. Okay, the input voltage Vn is shown in the figure applied at t equals to 0 millisecond to 6 millisecond. Obviously, the circuit, given that the initial voltage across the capacitor is 0.3 volt and the diode is ideal, the open circuit voltage output at 5 millisecond will be. Okay, tell me what is the answer. All of you can do this question in 1 minute very easily. All of you can do this question very easily. I hope all of you will be able to do it. Oh, why you are stressed? Just try to focus on whatever you have studied. Okay, even if you have done only 50% of the technical syllabus, then also a good rank is possible. Okay, stress will do nothing. It will only create problems. It will not solve anything. So there is no point in being stressed. Try to focus on what you have already studied and focus on it. Okay, focus only on what you have studied and skip what you have not. Okay. I hope all of you will be able to do this question very easily without even picking up your pen. There is no need to pick up your pen even in this case. So we can see that initially it will charge to 0.4, then it will charge to 1 and then it will be constant. So it's a peak detecting circuit. It is a peak detecting circuit and we can see that the voltage output will be 1. Why others are not able to do it? A very simple question. Even if capacitor value is given, there is no point in using it, because when the diode is on, capacitor will charge instantaneously, quickly. When the diode is off, capacitor voltage will remain fixed. Right? All of you are able to do it? Okay, next. We have done this now. What happened to this question? Let's solve this. You have done this question, na? You have done this question in the previous Hindi channel. We have done this question on the Hindi channel. right? We have done this question on the Hindi channel. Okay, now let's solve this question. I think all of you will be able to do it. So then try to find out why the marks are less, because if you have done 7 subjects, okay, including mathematics and FT, then obviously you must be getting marks around 50, So why you are getting 25 marks? I think you might be getting stressed by reading the questions of other subjects. Okay, your focus should be on the subjects that you have read and you have learned. Okay, so focus only on those subjects, will be able to do much better. Okay, so we'll do that one also, don't worry. अच्छा ओके, ये तो यहाँ से इम्पिडेंस पूछ, बहुत ही सिंपल. What is the answer? A, B, C or D? There is no need of transient equation. Okay, because when diode is on, the diode will be short circuited. So there is no need of transient in that case. Okay, what is the answer? A, B, C or D? We can see that the op-amp is in negative feedback, obviously. We can see that there is a virtual shorting. Op-amp in negative feedback. Okay, op-amp in negative feedback. So this terminal is grounded. V minus is 0. This is grounded. Okay, this is your VO. You can see that whatever current is going here, the same current will go here. Okay, we have to find out the input resistance. We can do that. So we can see that the current here is VI upon R. The same current will go here. So this will be 3 VI drop. The voltage here will be minus 3 VI. So now we can see that the voltage here is VI. This is minus 3 VI. So the voltage drop will be 4 VI. The current will be VI by R. So we can see that the total current here is VI upon R and 2 VI upon R. So the total current is 3 VI upon R. So input impedance is the voltage divided by current, that is R by 3. A is the correct answer. Others are also able to do it. Please check. First of all, we simply solve the circuit. VI, negative feedback grounded. VI upon R is the current. VI upon R will be the current. VI is the drop. Our voltage here is minus 3 VI. Now we can see that the current here will be 4 VI is a drop, resistance is 2R. So 2 VI upon R is the current, 2 VI upon R is the current. Okay, VI upon R is this current. So the total current is 3 VI upon R. Okay, the voltage is VI, the current is 3 VI upon R. Input impedance is Vin upon 3 VI upon R, R by 3 is this. Others are also able to do it. Please check. Others are also able to do it. Please check, all of you. Okay, great. Now let's see this question also. It's a very simple question. In the small signal circuit shown, the enhancement mode NMOS is biased in the saturation mode. Biased in the saturation mode with transconductance of GM. If the channel length modulation is ignored, the small signal impedance looking into the node P will be. What is the impedance? I don't think any problem is there in this question. Without using the pen, you can answer this. Without using the pen, we can answer this. What is the answer, दोस्तों? Okay, a very simple question. Without using the pen, we can answer it. Please answer. Okay, so we can see that we can easily draw the T model. We can easily draw the T model. Okay, the RS is here. Okay, we can see that the input impedance, impedance here is RS and 1 upon GM parallel. RS parallel to 1 upon GM. Very simple question. Okay, I hope all of you are able to do it. Great. On. We have done this question, right? We have done this question right now. This is okay. A very beautiful question, दोस्तों. Let's try to do it. We have to find out the frequency in kilohertz at which the voltage gain is 0 dB. Voltage gain is 0 dB. Let's try to do it. What is the meaning of 0 dB gain? What is the meaning of 0 dB gain? Try to solve it. I think all of you will be able to do it. हुआ दोस्तों? सबसे पहले आपको पता होना चाहिए दोस्तों 0 dB गेन का मतलब क्या है. वोल्टेज गेन इज 0 dB का मतलब है वोल्टेज गेन का मैग्नीट्यूड 1 हो गया है. ठीक है ना, गेन का मैग्नीट्यूड 1 हो गया है. ठीक है, अब यहां देखिए दोस्तों, आगे चलते हैं जरा. यहाँ पे आप देखोगे दोस्तों इसका गेन क्या आ जाएगा, ट्रांसफर फंक्शन क्या आएगा. तो ट्रांसफर फंक्शन आप बोलोगे सर Z2 अपॉन Z1 माइनस टाइम्स तो आ जाएगा दोस्तों दिस इम्पिडेंस, आप देखोगे दोस्तों आएगा माइनस 100 किलो डिवाइडेड बाय 100 किलो मल्टीप्लाइड बाय j⍵c, ये वाली कैपेसिटेंस, +1 डिवाइडेड बाय 10 किलो। अब आप इसको जरा थोड़ा सॉल्व करोगे तो ये 10 किलो और ये कटेगा तो आएगा -10 डिवाइडेड बाय 100 किलो और ⍵c मल्टीप्लाई होगा। 100 किलो मतलब 10⁵, 1 नैनो फेराड मतलब 10⁻⁹ तो आएगा दोस्तों j⍵ इंटू 10⁻⁻6 +1। प्लीज चेक करिएगा सही लिखा है, सही लग रहा है वैसे। -9 और 5, ठीक है, 6 बनेगा, ठीक है। तो आ जाएगा दोस्तों -10/j2πf इंटू 10⁻⁻6 +1। अब मैग्नीट्यूड 1 करना है दोस्तों, इसका मैग्नीट्यूड, इसके ट्रांसफर फंक्शन का मैग्नीट्यूड 1 करना है। क्या करेंगे, तो मैग्नीट्यूड इक्वल्स टू 1, तो क्या करेंगे, तो आएगा 10/√4π² f² 10⁻12 +1। इसको 1 करना है हमें, मतलब 100 इज इक्वल्स टू 4π² f² इंटू 10⁻12 +1, ये करना है हमें। एक बार चेक करिए सही कर रहा हूं कि नहीं। क्या आ जाएगा दोस्तों 99 डिवाइडेड बाय 4π √, डिवाइड बाय 4π। तो फ्रीक्वेंसी विल बी 1.5835 मेगाहर्ट्ज। प्लीज चेक करिए, किलोहर्ट्ज में पूछ रहा है तो आएगा 1583.5 15। एक बार मैं चेक भी कर लेता हूँ कोई गलती तो नहीं करी है। 100 किलो 1 नैनो -4 होगा ना, 6। 10⁻⁻4 होगा और 10⁻⁸ आएगा इधर। ठीक है, ऐसा हो जाएगा। सॉरी मैंने उसकी टाइप कैलकुलेशन हो गई। तो हमारी फ्रीक्वेंसी आ जाएगी दोस्तों 1.583 इंटू 10⁴, दैट इज 15.83 किलोहर्ट्ज। प्लीज चेक करिए, अभी ठीक है क्या, एक बार चेक करना। अभी तो कोई गलती नहीं लग रही है वैसे। एक बार चेक करिए क्या ये मैच हो रहा है दोस्तों। अच्छा गलत आ रहा है क्या, 1591.5 आ रहा है। किलोहर्ट्ज तो नहीं आएगा, किलोहर्ट्ज में तो नहीं आ रहा है, एक बार चेक कर लो। नहीं नहीं, आप 3 dB फ्रीक्वेंसी क्यों निकाल रहे हो? अरे यार आप लोग तो 3 dB निकाल के बैठ गए हो। इसने 3 dB नहीं पूछी है भाई, इसने 3 dB फ्रीक्वेंसी नहीं पूछी है भाई। इसने पूछी है फ्रीक्वेंसी जहां पर वोल्टेज गेन हमारा 0 dB हो जाएगा, मतलब मैग्नीट्यूड ऑफ द गेन 1 होगा। प्लीज चेक करो, आप लोग 3 dB निकाल के बैठ गए हो भाई। 3 dB नहीं पूछी उसने। एक बार देखो, सही से देखो, चलेंगे आगे, एक बार चेक करो। चले आगे बच्चों, हुआ आपका, चेक हो गया, सही कर लिया आप लोगों ने। चलिए आगे चलते, नेक्स्ट क्वेश्चन। ओके, लेट्स मूव ऑन टू द नेक्स्ट क्वेश्चन। करिए। R1 R2 दे रखा है, बेस एमिटर वोल्टेज 0.7 है, कलेक्टर एमिटर 5.2, बीटा पूछा है। चलो करो जल्दी, सिंपल है, इजीली हो जाएगा। ओके, हुआ मेरे बच्चों? अरे हो जाना चाहिए था अब तक तो, अरे हो जाना चाहिए यार, इतनी टाइम लगना चाहिए। चलो ठीक है, तो R1 इज 100, R2 इज 1, ठीक है। चलो ओके, ये कितना दे रखा है हमें? ये दे रखा है 5.2, मतलब फॉरवर्ड एक्टिव मोड में है। ओके, अब क्या करें? अब आगे चलो भैया, बीटा पूछा है तो आप देखोगे सर यहाँ पे कलेक्टर करंट फ्लो करेगा, यहाँ पे बेस करंट, और यहाँ पे एमीटर करंट। ठीक है, अब क्या करें? और क्या है? 0.7। तो आप देखोगे दोस्तों, बड़ा सिंपल सा क्वेश्चन है। यहाँ पर अगर हम देखें तो यहाँ पे 12 है, यहाँ पे 5.2 है, तो यहाँ पे कितना आएगा दोस्तों? यहाँ पर आ जाएगा 6.8। एक बार चेक करो, तो 6.8 इज इक्वल्स टू R2 की वैल्यू है 1 किलो ओम, तो 1 इंटू IE, ठीक है। यहाँ पर आप देखिए दोस्तों 5.2 है, ये 0.7 है, तो इसके अक्रॉस ड्रॉप होगा, बाकी का कितना हो जाएगा इसके अक्रॉस ड्रॉप? 4.5। 4.5 इज इक्वल्स टू 100 इंटू IB, ठीक है। अब दोनों का रेशियो ले लेते हैं, तो आप देखोगे दोस्तों 6.8 अपॉन 4.5 इज इक्वल्स टू बीटा प्लस 1 IB अपॉन 100 IB। क्या है, सही है? यस ऑब्वियसली। तो आप देखोगे IB कैंसिल हो जाएगा, तो बीटा प्लस 1 इज इक्वल्स टू 100 मल्टीप्लाइड बाय 6.8 अपॉन 4.5। यहाँ से बीटा आ जाएगा, कितना आएगा? बीटा की वैल्यू आ जाएगी दोस्तों 150.11। क्या है? ठीक है, एक बार देखिए दोस्तों, ऑल ऑफ यू आर एबल टू डू इट, तो ऑल ऑफ यू आर एबल टू डू इट दोस्तों। तो बीटा इज 150.111, 151 कैन बी अ रॉन्ग आंसर, 151 कैन बी अ रॉन्ग आंसर, 151 कैन बी अ रॉन्ग आंसर। प्लीज चेक, ऑल ऑफ यू आर एबल टू डू इट, प्लीज चेक, ऑल ऑफ यू आर एबल टू डू इट। Okay, so let's move on to the next question. This one a very beautiful question. Today itself, I think someone has asked me this question on Telegram. Today itself, someone has asked me this question in the Telegram. A very beautiful question. Let's try to do it. Just try to do it, dosto. A very beautiful question. LC oscillator with a diode. Okay, so let's try to do this. A very simple question, dosto. First of all, we'll do a capacitor and inductor is there. Capacitor is 10 microfarad. This is this. Capacitor is charged. So we know that the capacitor, charged capacitor can be written like this: VO upon SC, VO upon S. So it is 10 upon S, charged capacitor. The capacitor is 1 upon SC. And if we remove the switch and the diode for some time, this will be the inductor. Okay. So now, what will be the current in this case? The current. So we can see that if we remove the diode for some time, we can see that the current in Laplace will be 10 upon S divided by SL plus 1 upon SC. This will be 10C divided by, or we can say we multiply by we take it like this: 10 upon L divided by S square plus 1 upon LC, right? We do it like this. This is your current, and okay. And what will be the voltage across the capacitor or across the inductor? We can easily find that also. What will be the current? What is this? What is this? So we can see that this current will be in Laplace. This is the current is I think cosine, right? This is your sine wave. This is your sine wave. The current IT will be sine wave 10 upon L divided by, or we can say it is 10 upon L cos omega t cos omega naught t ut. What is the Laplace? The Laplace is S square plus omega naught square. Is this correct? I think ये उसका होगा. So sine, the cosine Laplace transform is, I think, S upon S square plus omega square. Please check, all of you. and sine omega naught t ut as Laplace omega naught upon s square plus omega naught square, right? Is this correct? I think please check. Now, so here we can see that IS can be solved like this, right? So from here we can see that if we compare this, so in the numerator we should have omega naught. In the numerator we should have omega naught. So we multiply divide by under root 1 upon LC. Okay, we multiply divide by under root 1 upon LC. So under root 1 LC and 1 upon under root LC divided by S square plus 1 upon LC. Okay. So by simple changing we can get this result. This is your IS. Now this will become a sine wave or the sine equation, and we can see this will be 10 under root of C by L sine of omega naught t, and the omega naught is 1 upon root LC. We can simply put the value of C or L and we can find out the current. This is the current that we have got, and obviously we don't need to this is the correct answer because we know that initially the inductor was uncharged, so the current has to be 0 at t equals to 0 plus. At t equals to 0 plus the current has to be 0, and thus the current has to be 0 at t equals to 0 plus. So this is the correct answer. The current IT is perfectly fine. Now what will be the voltage across capacitor? If we find out the voltage across capacitor, so we have the current, we can find out the voltage across capacitor. This is the total voltage plus minus. We can see that the total voltage across capacitor will be 10 upon S minus current multiplied by 1 upon SC. This will be 10 upon S minus S divided by SL plus 1 upon SC, 1 upon SC. Is this fine? The voltage across the capacitor. Is this fine, dosto? All of you are able to do it using some Laplace property. Now, you must have solved this in your network theory classes. You must have solved this LC circuit in your network theory classes, right? Now, I am just trying to give you a brief overview of that topic. Now, we take 1 upon S common. Ten minus 10. Let's take 10 upon S common, pura completely. We can take 10 upon S common. So it is 1 minus 1 upon S square LC plus 1. Right, like this. Take it. We take 10 upon S common. So it is 1 minus 1 upon S square LC plus 1. Right. So it is 10 upon S common. S square LC plus 1 minus 1 divided by S square LC plus 1. So this will come out to be 10 S LC divided by S square LC plus 1. We can take LC as a common. So it is 10 S upon S square plus 1 upon LC, and this will become a cosine 1. So the voltage across the capacitor will be 10 cos of omega naught t. So we can see that the current and the voltage, the current in the circuit is sinusoid like this. If we don't have the diode, and the voltage across the capacitor will be the cosine wave. Okay, like this. Okay. So we can see that the current in the circuit will be a sinusoid and the voltage across capacitor will be like this, cosine. Is this fine? Now, but here we have a diode also connected. So it is very obvious that initially the voltage across capacitor is positive. When the switch is connected, since the voltage across capacitor is positive, it will throw the current and diode will allow the current to flow. But diode will allow only the positive cycle. Till here, from here till here. Similarly, the voltage across capacitor will also be till this point only. After that the cycle will break. After that the cycle will break. So the current will be in the positive cycle and the voltage across capacitor will start from 10 and will go to the minimum value or the minimum peak value, that is minus 10. Okay, so something like this is there. So the diode will allow only the positive cycle and capacitor will go like this only. So we can see that. This is connected. Okay, and the current will flow only in the positive cycle, only for the positive cycle, and the capacitor will get the minimum value minus 10. Okay, and after that the current flow will stop and the cycle movement will also stop. Now we have to find out the time also. मैं तो वो आपको बता दिया था. But if we talk about the time also, can we find out the time duration? Yes, we can. So let's find out the time duration of this. What is the omega? Omega is 1 upon under root LC. What is this? 1 upon under root of LC. L is this, C is 10 microfarad. So we can see that the omega is 10,000. So frequency will be 10,000 upon 2 pi. And the time period will be very small. Time period will be in milliseconds. So we can see that this time period will be in milliseconds. Okay. After that, the current flow stops. And the capacitor voltage takes minus 10 as a fixed voltage. And if they are asking the voltage across capacitor at 0.5 seconds, which will be very, very far away, and we know that, after this half cycle, the voltage across capacitor is constant. So at 0.5 seconds, the voltage across capacitor will be minus 10 only. And similarly, after this half cycle, the current will be 0. So even if we find out the frequency and omega, we can see that the time period of the cycle is very, very small. So 0.5 seconds will be far away. You don't need to worry about it. All of you are able to do it or not? Please check and revert. All of you are able to do it? Please check. So we have solved this question, a very beautiful question. Please check. Okay. All of you are able to do it? Okay. Thank you, dear students. We'll end the session right now. Okay. I hope all of you will be able to do all the questions in your GATE exam very easily. Okay. Thank you. Bye-bye and take care and all the best for your GATE exam. We'll meet again.